All right, time to get started here. Good morning or afternoon, depending on where you are. Welcome, everyone, to this Zend webinar. Today we're going to be talking about the new SPL features in 5.3 with Matthew Turland. I would definitely like to thank Matthew for coming here and giving this webinar with us. But before I hand the reins over to him, just a couple of ground rules here. If you have any questions, do feel free to put them into the Q&A panel on the bottom of the WebEx toolbar. What we're going to do is we're going to let Matthew go through his presentation here, and unless there's something that absolutely needs to be asked at that given point in time, we'll wait until the end of the presentation in order to answer the questions. That way, Matthew can focus on what he's doing and get through all that. So if you have questions, put them any time that you want into the Q&A panel, but we'll only be getting to them at the end of the presentation unless there's something pressing that needs to be addressed. An additional note about the recording: this webinar is being recorded and it will be placed on the Zend.com website within the next week or so. And so you can go to the Zend.com website and find it there, or you can just look on our Facebook page. And I'll be posting a link to the webinar there once it's up on the Zend.com website. To find our Facebook page, just go to Facebook and type in Zend Technologies into the search, and you'll see us right there. So with that, those I think are enough of the house cleaning items. Matthew is our speaker here. He's the senior engineer on the platform team at Synacor. He is the author of PHP Architect's Guide to Web Scraping with PHP. He's spoken at both ZendCon and PHP Tech. Actually, I think it was at this year's ZendCon that Matthew and I ran into each other, actually at the airport, waiting to head home. He's also the lead developer on the Fergie project and also a contributor to the Zend Framework project, as well as an organizer for the Acadiana open source group, and he just does an awful lot of stuff, and it's all PHP related. So we're really glad to have Matthew here, and with that, Matthew, feel free to take over the reins and show them what you got. Of course, we'll have to unmute you.
So, Kevin covered a good bit of this already, but for those of you who are not familiar with me, I am a senior, one of the engineers at Synacor. I have written for PHP Architect in the past. I've also done technical editing for them. I have a book out if you're interested in web scraping and you work with PHP. I don't tend to mention my degree too much, but I do have a degree in computer science, a bachelor's, and I think it's relevant because a lot of the background of the material today that we're going to cover relates to that particular field. So, before we get started, a quick note about where I work. Synacor provides internet solutions to ISPs, media companies, advertisers. They have offices in Buffalo and in New York City, though I actually work remotely for them from my home in Louisiana. Their clientele includes most of the top 20 cable providers in the country, and they're a pretty great company to work for. I've only been working with them for just under a year now, but I've really enjoyed it. So if you are in the market for a PHP-related job, I urge you to consider them. Okay, so this would normally be where I kind of poke the crowd and ask who has any sort of experience with PHP 5.3, SPL, computer science, data structures, and so forth. I think it might be a bit tedious to get a list of hands, but so just bearing in mind, these are a list of related topics that I would normally be asking you about just to kind of gauge your experience level. Okay, so looking at the SPL prior to 5.3, just to give you an idea of what's new. What we had in SPL at that point was mainly stuff related to iterators, although there were a couple of other things as well. Array object, SPL file info, so the subject observer implementation, to give a few examples of those. Iterators, a good number of those for, as an example, recursive iterator, filter iterator, limit iterator, things that allowed you to simulate arrays, like array object and array access and countable, the various iterator-related interfaces. And also stuff, obviously, you're probably more familiar with the stuff related to autoloading, as in registering a custom autoloader. So most of the newer stuff has to do with what are called containers. These are classes intended to be data structures, just containers for data, that have that basically contain more than one element. They're similar to arrays in that particular respect. The difference being that they store their data in an organized way following a specific set of access rules, generally with the intent to increase performance. Now, the first question that a lot of people ask when they read this sort of thing is, okay, well, we already have arrays and strings, the proverbial WD-40 and duct tape of PHP in terms of being able to take data apart and put it back together in various formats. So why do we need these? Basically, if you're dealing with any sizable data set, the main reasons are that in terms of being able to store data in these containers and pull it back out again and access it, you have the chance to have either less CPU usage or less memory usage or both when you're working with these data structures for the most part. So if you are being very conscious about performance, even though these may be micro optimizations, if you're not working with large data sets, they are an option to consider when you're trying to improve. So arrays, in general terms, are fantastic. They are a great general purpose data structure for being able to store data the way that they do, allow you to access it the way that they do, and maintain the level of performance that they have. Underneath the hood, if you actually look at the PHP source, and I think I've linked to I've linked to the actual area of the source that deals with this particular algorithm. Arrays use what's called a hash table algorithm, which basically means you provide a key to the array, and it passes that key through a function that eventually resolves it to a specific element in an array that's stored internally by the Zen engine. So this allows you to use any number of keys, integers or strings, whatever, and to maintain good memory usage, good performance for lookups for this general purpose usage. For more specific features, they're not so great. So, fair warning, we're going to be looking at benchmarks. Obviously, these should always be taken with a grain of salt. I've included all the specs here on the last time that I actually executed these. And then I've actually taken the result and graphed them so we can actually visualize them here in the presentation. If you want to get access to this stuff, the code and the results, my current set, are on GitHub. So you can take a look at them in there in your spare time. So we're going to start going through the data structures at this point. I'll introduce you to them, tell you what they are, when you should use them, and how they compare in terms of performance to arrays. So we're going to start basic and look at basically a list. So SPL fixed array is very similar to an array, but it has a few more restrictions. First off, when you create it, you specify the maximum number of elements that you're going to have inside it. It only uses integer keys starting from 0, and they are intended to be contiguous. You can resize the object later once you've created it, but it kind of defeats the point of using it in the first place, so you generally tend to want to avoid that. And another bad thing is it's not compatible with any of the existing array functions. So this is a case where you just want a sequential list of items that you want the ability to iterate over. So as a very contrived example, if you were pulling data from a MySQL database and you wanted to store the results into some sort of structure that you could iterate over, at the point where you've executed the query, you know how many results you're going to get back. So that would be an instance where you could use this. So looking at an example of code where this is actually used. So at the top here, I have an example where I'm basically just shoving elements into an array and then accessing them back out again. And then I have a very similar example further down where I'm doing the same thing with an XPL fixed array instance. I'm making calls to argv here because I'm actually running these examples from command line. These are actual source code examples pulled from GitHub. So you'll see the examples look very similar. SPL fixed array implements array access, so aside from the declaration here, they are pretty much the same in terms of how they're used later on in the code. Okay, so in order to visualize this, what I did was, rather than looking at the amount of time that it took to perform a single execution, I inverted that. So I'm actually looking at the number of executions per second for each of these code samples given a certain number of elements to see how long it takes to process them. So in this case here, I actually get more out of SPL fixed array for a smaller number of elements by a pretty wide margin. Going further up into 100, 500, 1,000, and 5,000, which were the units of elements that I used for all of these examples. The difference is not as extreme, and in some cases it may vary just depending on your server load. So something to keep in mind: if you have a list of elements that are under 100, that's probably a pretty good use case for this. Memory usage starts out about the same. It eventually starts to become more pronounced over time, simply because, as I mentioned before, we're having to store both keys and values when we're using a hash table, or at the very least, well, yeah. So that's probably part of what's contributing to the difference here that you're seeing over time in terms of memory usage. Okay, another class that emulates a list is the SPL doubly linked list class. This is mainly intended to be a parent class, to be extended. It has the same unlimited size as normal arrays versus SPL fixed array, which is, as we said, fixed. But it does not have the overhead of the associated hash map algorithm. It's slightly less performant simply because in order to access anything in the list, you're not giving it a hash key, having it evaluate it through a hash function, and then resolve that to an element. You actually have to go and iterate through the entire thing. Well, I say the entire thing, up to the point where you want to access it to find whatever you're looking for. At the moment, element insertion is only allowed either at the start or at the end of the list. There is actually a feature request that I've linked to here to add functionality to add in an element elsewhere. So if you are interested in that, just go ahead and upvote the bug. So it's best to use these when you don't know how many elements you have to store in advance. You still only need to access them in sequential order. You're more concerned with memory usage potentially than with runtime necessarily, and you're dealing with a fairly large number of elements in general. So again, very similar example here. Rather than specifying an index, I'm simply just appending to the end of the list in both cases. So looking at the results, this is an interesting anomaly as these classes go. You're seeing here that arrays will actually outperform SPL doubly linked list, just as I said, because you're not doing a direct lookup for the element. You're actually having to iterate over to find what you want. So it's not so good in terms of execution. However, in terms of memory usage, there is a difference, especially as you start getting up into using more and more elements. Okay, so looking at a new data structure called the stack. At this point, I think, is where most people are not aware of the data structures that we'll be discussing. Okay, so stacks, as a general concept, generally have two operations. Push, which adds an item onto the top of the stack. In this case, you can use the open square bracket, close square bracket operator that you use for arrays normally to just append to the end for both arrays and stacks. To remove an item from the top of the stack, you would either call array pop on a normal array, or you would call the pop method on the stack class. This is what's called the last in, first out data structure, which means that the last item that you push on top of the stack is going to be the first item that you pop off the top of the stack. And stacks, that's their limitation as far as data access. You can only get access to the last element that was placed onto them. PHP diverges a bit from this because SPL stack actually extends SPL doubly linked list, so you can actually do things like iterate over it, for example. In this case, it's good to use them when you don't know how many elements you want to store. You only ever want to store the last element that you put onto the data structure, and again, you're more concerned with memory usage necessarily than with runtime. So this is the array example, where this is fairly similar to the code that you've already seen before. Further on down, I'm actually calling array pop to get items off of the end of the array. Versus this example, which the only real differences are how I'm declaring how I'm initializing the variable, and then the method that I'm using to pop items off the end. Other than that, they're identical. Okay. SPL stack, like its parent class in the example that I showed, in terms of execution, you're probably going to get better results out of arrays for smaller collections of elements. As you get up, the difference is a lot more marginal. In terms of memory usage is really where you see the difference as far as the stack is concerned. This has been kind of a trend thus far, but we'll see that change here shortly once we get into more complex data structures. All right, the queue. Pretty much anybody here who's waited in line is probably familiar with this, or at the very least anyone who's dealt with a printer. So again, two operations, adding an item to the queue, which same operation for both the stacks. Other operation is dequeue, which actually removes an item from the front of the queue. So it's analogous to the array shift function versus the dequeue method of the queue. So this is in contrast to the stack in that it's a first in, first out data structure, which means that the first item that was added, or rather the item that was added earliest, at the end of the queue is the first item that will be removed from the front. Okay, so again, best to use these when you don't know how many elements you want to store and you only ever want to access the remaining element that was stored earliest. I think most people are probably familiar with queues here. So again, referring back to array shift, this example is pretty much identical to the one that I used for stack earlier for arrays, just the difference being that we're using a different function here to remove from the front, but we're still appending to the end. Versus the queue, which again, the only difference is really just initialization here and then calling a dequeue method here to get items off the front. Alright, so execution time for a small number of elements is not very good, but the queue does eventually overpower the array once you get into several hundred elements. And then in terms of memory usage, it's got a pretty similar pattern to what we've already seen so far. The difference is going to be marginal for smaller numbers of elements, but as you start getting larger and larger, the difference will become more pronounced. Okay, here's where things start getting interesting. A heap, again, has two operations. Inserting an element into it, which a heap is unique in that once you insert an item, it doesn't actually stay, I should say where you sort it, but that's kind of an odd thing. Once you add it, it's that the heap internally actually places the element appropriately based on how the other elements compare to each other. So as you'll see in a minute, to get the same effect out of arrays, you would basically have to sort the array on each insertion. Reasoning behind this being that you may not have all the elements that you want to add to the structure at the same time. They may come in over time, especially in the case of a long-running process. So the other operation being simply just removing an item from, which in this case, if you were using this approach with arrays, would be again shifting off the top since you're sorting, versus the extract method of heap. What's kind of neat about the heap class here is that you can actually extend heap and override the comparison method. So you're able to store whatever type of data you want and then define how objects are compared to each other so that you can use the heap class with anything. Natively, there are two particular implementations that are provided, SPL min heap and SPL max heap, which effectively give you the smallest and largest element in the heap respectively at any given time once you extract. In terms of performance, internally, arrays use, for the sort function at least, use the quicksort algorithm. The heap sort, which is what you would be able to implement using this heap class, actually has better worst case performance if in scenarios like where your elements are almost already sorted once they're presented. Okay, so this is a visual diagram. What you're looking at here is a max heap. So in this case, the root of the heap here is the largest element, and then as you trickle down, the elements get smaller and smaller in comparison to each other. So what this does is once an element is shifted off, the elements are rearranged internally so that in this case 10 would be the new root of the heap. And it is able to do this with a minimal number of comparisons. So that's part of what contributes to its efficiency. So if you don't know in advance how many elements you have, and you need to access them in an order based on how they compare to each other, that would be a good use case for this data structure. So what I'm doing in this example is a bit more contrived, but bear with me. I'm generating numbers between 1 and whatever my number of elements is, and then I'm resorting to simulate the same effect as inserting into a heap, where it performs the comparisons and then places the element appropriately. And then I'm shifting elements off, at which point here they should be sorted. So looking at the same code for min-heap, which is what I'm using in this example, I initialize, I insert a random number into the heap, and then I start extracting them out, at which point they should again be sorted. So it's unfortunate that this is the best way that I can approximate this with arrays, because it's not entirely a fair comparison, but in terms of the purpose for trying to get arrays to do something, like be able to order array elements over time, if you had some sort of a long-running process where you would get data over time, this is the closest I can get. But looking at the execution time, if this is what you're trying to do with your data, then the difference in execution is no contest. Heaps, especially with larger numbers of elements, scale a lot better than arrays for this sort of thing. And again, the memory usage in this case is pretty equally pronounced, especially as you start getting up higher into larger numbers of elements. It can actually be up to half, starting at about 5,000. Okay, the priority queue. This is very similar to a queue, difference being that elements are internally reordered based on priority. The closest equivalent that I could really give to this in the real world is medical triage, where if you have somebody in an ER that may have a bad case of the flu, and then you get a new patient in that has life-threatening injuries, obviously that one's going to jump precedence in the queue even if they got there later. So that's the same idea with this particular data structure. It accepts a priority with each element that you add in, and then elements are reordered internally by that priority rather than by their own value, and then they're removed in priority order as you remove them from the queue. Priority values themselves can be of any comparable type. Again, you can override the compare method that SPL priority queue has to add in your own logic for comparing priority values. It operates similarly to a heap in this respect in terms of comparisons, and in fact it actually uses a heap internally for storage. It's best to use this when, again, you have any number of elements but you want to access them in an order based on some value other than the value that you're actually storing. Okay, so this code is a bit extensive. What I'm doing here is I'm defining a threshold of 1/10 of the elements. I'm going through and I'm adding them in, and then I'm sorting by priority order on each insertion, which is the way that the queue operates, similar to the heap. And once I get to a certain to that threshold, then I'm starting to shift items off until there aren't any more. This simulates the effect of being able to insert elements with random priorities over time and shift them off again, and still be able to maintain priority order as they're inserted. So the equivalent code here with SPL priority queue is defining the same threshold, initializing the data structure, calling insert with a random priority, and then threshold. Once that's hit, I start calling extract until the data structure is empty. Okay, so for smaller numbers of elements, there's still a pretty distinct difference, roughly about, I think, 900 executions per second, and then again, as you start going up in the number of elements, the difference becomes more pronounced. In some cases, I wasn't able to get even a single execution per second out of arrays, so hence you start seeing that disappearing from the graph here. The differences in memory usage are not as pronounced here, so you would generally want to use this for runtime efficiency. Okay, sorry, one moment. Getting a bit hoarse. Okay, so sets. The best way to explain sets is really it's a data structure that focuses more on groups of elements and membership in that group versus individual elements themselves. So the reason that I'm also going to introduce a composite hash map here is that the next data structure actually implements both of these, set and composite hash map. So in this case, I showed you a picture of what a hash map looks like in terms of how it functions. The difference with a composite hash map is that it actually uses objects for keys rather than scalars. Some people don't know this or never thought to actually try it, but you can't use non-scalar values as array keys on normal arrays. It has to be a scalar type, like strings or integers or what have you. So the composite hash map actually allows you to store data and key the container by an object. Okay, so SPL object storage is the data structure that implements both of these. You can actually do this with arrays, but instead of referring to an object literally as the key, you would have to pass it through an object called SPL object hash. In the past, I think this was corrected around early on in 5.3. There was a performance issue where SPL object hash would take significantly longer to be able to perform this functionality than SPL object storage did. That has since been corrected, I've been told, so the difference is probably a bit less. And again, the set being a group of values that focuses more on things like membership. Sets have operations like union, being able to combine two sets into one. Intersection, being able to find elements that are common to multiple sets. Difference, being able to find elements that are not common to both sets. Element of, seeing if an item is in a particular set. Sets don't have any real concept of order. Again, they focus more on just on whether or not an object is in, or whether it's in multiple or not in multiple, or so forth, rather than being able to do things like iterate over a set. Doesn't really make sense. One thing I should mention is that the intersection operation, again, which is finding elements that are common to two sets, was not actually present until 5.3.6. I know this because I actually wrote the patch for it myself. So the element for that is remove all except, if you're interested in doing intersections. So it's best to use this particular class when you want the ability to store data with non-scalar keys, and you want to use something that's a bit more object-oriented than the older strategy of using SPL object hash with arrays. Or you want the ability to access data with set operations rather than based on their particular order. There are array functions to do some of these operations that I'll be showing you, and in fact I use some of them here. So this is the array example. Here I'm initializing an array, I'm storing objects, which I'll be doing with the SPL object storage example in a second. I'm using SPL object hash to get a hash for that object. Further on down here, I'm generating random numbers, and then I am using array merge to do a union, and then array diff to do difference. So those are the particular operations that I'm testing: storage, union, difference. Looking at the SPL object storage equivalent, initialization, declaring a new object, attaching that, and I'm using the object for both the key and the value here. I'm actually using it as a composite hash map. Further down, defining two new ones, attaching random numbers. In this case, since I'm using them as a set, I actually have to store an object. It is actually possible to cast a scalar to an object. You may want to read up on how this works with typecasting in PHP, but just so you know, this does actually work, even though it looks a little funny. The methods on SPL object storage work inline. That is, that they will modify the data structure that they are called on. So in this case, what I'm doing in order to maintain the original data structures is I'm actually cloning those objects. So I'm doing an add all to perform a union here, and then I'm doing a remove all to do a difference. I should probably amend this example because at the time that I wrote it, remove all except was not available, so it's not included here. But okay, so execution-wise, you do get a bit more. The difference isn't quite as pronounced as data structures that we've already reviewed, as the number of elements increases. So the difference is still there. It's just not quite as pronounced. The real difference here, as you get up, is really just in terms of memory usage. In this case, unfortunately, SPL object storage does tend to take up a bit more, I think, partly because of how it's probably related to how it's being used as a composite hash map versus a set. So if you're using this to get out more execution cycles, you may want to be aware that it is going to use up some more memory. Okay, Etienne Canus, who is the person who did a lot of the work to get these data structures into Vive 3. I've actually communicated with him before. He's the person who merged the patch that I submitted. He's not as available or as active in working on it as he used to be. He's at university at the moment, but great guy, was very willing to work with me, so if you have a problem, I'm going to blame him in this case. Some SPL resources that I've found very handy. The manual section has actually gotten to be a lot better than it used to be. It used to be limited to the old Doxygen docs, which are still linked in the introduction, but it actually goes over a lot more of the data structures that are available and the iterators that are available. It is not necessarily comprehensive, so you may want to go digging in the old Doxygen docs if you don't find what you need in the actual proper manual section. Etienne also blogged as he was developing these new data structures, so he does actually have older blog posts that discuss them at a bit more depth. If you want to look at some of the stuff that was available pre-5.3, Elizabeth Smith has an excellent presentation called SPL to the Rescue, and I've linked to the slide deck here. Same with Michelangelo Van Dam. He's got another similar one. It's called SPL, A Bridge Not Too Far. If you want to review this material in a more expositional format, I've actually got it in blog post form and then amended slightly and repurposed for inclusion in PHP Architect itself. It was last month's issue. If you received that, you can take a look at it there. Some possible future SPL additions that discussed with Etienne. I don't know if or when these will come about, but these were definitely possibilities. Graphs, in particular, have kind of gained a little bit of notoriety, especially for things like social networking. So being able to do things like define nodes, edges that connect them, directional graphs, being able to support cycles, as in multiple nodes, eventually pointing all the way back to each other. Connected and unconnected graphs, being able to refer to costs of a particular edge for doing things like finding the shortest cost or distance or time flight from one point to another involving connections. That's another famous application. And trees, which are a variation on graphs. You've probably seen them if you've done anything hierarchical, like sitemaps or family trees or things of that nature. So these may or may not be included in future releases. And at this point, I'll go ahead and open up the floor to questions. I know I kind of went through that material a bit quickly, but again, if you're interested in finding out more about where I work, you can check out Synacor.com. They're also on Twitter. You can also check out my website, MatthewTraylor.com. Email me. I'm also on Twitter, and IRC as Elazar. And that's it.
All right. Thank you very much, Matthew. I almost called you Elazar there. We got a couple of questions here going on here, but before we go on to the individual questions, do you have a link to the blog post on SPL available? Or can people just go to your...
Yes. If you go to my website and look under publications, I'll actually be including a link listing that this presentation was given on this date as a Zen webinar, and you'll be able to go directly to these slides, and they link to the blog post here.
Okay.
Toward the end. So yeah.
Okay. Well, if you have questions, now's the time to ask them. We've got a couple here already. The first one is, why is SPL limited to a small subset of data structures rather than being more encompassing in comparison to the standard C library?
I think that is the eventual intent. I think the short answer is basically just contributors, people working on it. Marcus Borger did a lot of the original work on the stuff pre-5.3. Etienne did a lot of the stuff that was added into 5.3. I think it was limited to a small set of commonly used data structures just simply because of the time involved. I believe he's working, he's in university. He was the main driving force behind adding this stuff on. So eventually I would personally like to see the addition of these more encompassing data structures. Up to this point, their implementation in PHP in general is still kind of limited. There is another one that I reference in my blog post called Bloomy. It's on PECL. Andrei Saminsky wrote it, I believe, while he was at Dig, but it implements a Bloom filter. It just wasn't included in SPL. But if you are familiar with C or PHP internals, or if you're inclined to become familiar and you do have knowledge of data structures, I would highly encourage you to try to contribute.
All right, next question. This one could have a very wide answer. Please compare. First of all, they state that it's a question from a beginner. Please compare and describe the features of SPL, Pair, and Zen Framework. If an application is developed in Zen Framework, then when should SPL and Pair be used?
It's really not intended to be general purpose. I think Pair, in particular, is a collection of library components. Zen Framework is a good example of a loosely coupled framework where you can kind of mix and match what you want to use, selective features from the framework, and then pull things in from elsewhere. SPL, to my knowledge, if you have PHP 5, is a core extension, so it will always be available. And in fact, I think with 5.3, it's actually a lot harder to have it not be available than it used to be. And it's mainly geared, like I said, toward making your classes iterable, operate like arrays, or being able to employ data structures to access data in a particular way to eke out less memory usage or more performance. So I would say use them in the scenarios that I described, depending on how you're trying to use your data, and really you should be able to use them in conjunction with any library or framework that's current. I think part of the difficulty that you may run into is that they are not always analogous to arrays. They do not always support the same things. That's been sort of a long-standing problem with the array object class, is that it doesn't have equivalents for some array functions and it's not compatible with them. So I don't know that you'll see a lot of libraries using them. I think that there are plans to use them in ZF2 and its internal code where it makes sense for performance, depending on what's being done with data. So yeah, like I said, it's not really as general purpose. It's more for specific data usage, depending on how you're trying to access or store your own data, that you would use SPL, and that you would generally probably use it in conjunction with those libraries rather than in place of. The purposes behind each of them are different.
Thank you. The next question is, any plans to have SPL types in core instead of PECL? Would love to use, but cannot even get them to compile.
To my knowledge, that extension, I don't think it's still being actively maintained. I agree that it is interesting. I don't know about its inclusion in core. I think that's been kicked around in internals a few times, and there hasn't been enough of a voice to try to get it in. I myself have only made minor contributions to it, just in terms of documentation and a patch or two, so I can't really speak on its future development. I think it really depends on the number of people that are speaking out for its inclusion, for the inclusion of that, and really any other new features. A lot of it is community-driven. It's a meritocracy, basically. It's based on who's willing to step up and put forward the work and who has the knowledge. So I know that the past major contributors to this particular extension are basically tied up in their own real-life situations at this point, their own jobs, their own family obligations, their own education. So it's just about finding a volunteer or two or several to keep this going.
All right, next question is for SPLQ. Do you think changing the iterator mode would have memory consumption, or would it, I guess, have a benefit on memory consumption, specifically IT mode delete?
Possibly for larger numbers of elements. It's really, you're really getting into more so how the Zen engine deals with garbage collection, I think, in this instance, than any particular facet of SPLQ. I would tend to think that it would. I don't know how timely the memory regain would be in deleting elements. That may or may not have a specific relation to SPLQ's implementation, but I don't know enough about the internals to be able to accurately answer that question. That would probably be a better question for Etienne.
All right. The next question is: are we planning to include in PHP.ini or include? Let me start over again. Are you planning to include in PHP ini directives to use SPL types as default, so PHP could be considered a type-enforced language?
As far as I know, there are no specific plans for that. I know that on internals, scalar type pending has been kicked around a lot. I don't know that there's been any real resolution to it. Actually, I think it was implemented. I think it'll be in 5.4 or whatever the next version of PHP happens to be. It won't be SPL related specifically. It'll be, as far as I know, it'll be limited to scalars, int, string, that sort of thing. So, in that respect, I think inclusion of SPL types is probably a bit of a moot point. Main difference being that I think it mainly handles emitting errors if parameters don't conform to known types or can't be cast to them. And obviously, in the context of SPL types, you'd be able to treat them as objects, but so I really don't have any sort of definitive answer other than I'm pretty sure it's been included as a feature of the language itself with no relation to SPL types in whatever the next major PHP version is.
All right, next question. Looking at the benchmarks, especially from earlier, it looks like the main benefit of SPL data structures is to reduce memory usage. This gives me the impression that they may be better for command line scripts. Was that the intention, or was it something else?
In general, yeah, I'd say that's probably a pretty accurate assessment, especially in cases where, like I said, you may have a long-running process that's dealing with data over time. For some of the later ones that we looked at, where, as an example, say with heap, if you were getting all your data at once and you were able to sort it then, that would probably be more efficient. But in some cases, like we said, you may not. So it really depends on your use case. But for the ones that have less complex algorithms, the list, the stack, the queue, yeah, I'd say that's pretty accurate. It's not until you start getting into structures that are based on comparisons, where you might have data coming in over time, that you start to see a large difference in execution time versus memory usage.
I also think, too, that some of the, when you start looking at some of the different features, that what it does is also, specifically with SPLs, what it does is it allows you to take a look at the problems that you're having and seeing if there's something that you can solve in a more native fashion, as opposed to you're just building another array. If you're doing something that's more queue-like, or if you've always wanted to use, or if there's times when you could use an object as a key as opposed to having to create a string representation to serve as a key in an array. Those kinds of things as well. So while there are memory benefits and things like that, I also think that too, that from just an application structure perspective, that a lot of this stuff allows you to build a more structured and more intentional application. I guess.
Yeah. I think you're referring to some basically code semantics. Yeah. Being able to tell more about the code by what data structure you're using in cases where it doesn't necessarily compromise performance. You can look at a variable initialization and know, okay, they're using this as a queue, versus an array that you may not know what they're using it for further on down the line. You can tell immediately. It makes the code a bit more self-expressive.
Yeah. Next question is here. Will PHP compilers come into the picture soon?
To my knowledge, they already to some extent have. Take a look at Hip Hop and PHPC and Roadsend. I don't know how active. I know Hip Hop is still active. I don't know if PHPC or Roadsend are still relatively active. To my knowledge, they're still around. Another point for compilation related interests is looking at the language implementation on other platforms. Off the top of my head, I know that Quarkus is one in Java and Phalange is one in .NET. I don't know how active either one of those are either. Obviously, they eventually resolve to compiled language, or well, I say compiled. They have some compile time optimizations versus those languages, but if you're interested in compiling PHP, those are areas that I'd look. Not entirely sure how that relates to the current topic of conversation, but okay.
Well, that's why I kind of snickered a little bit when I read that. Yeah, the first question that I would have would be on the purpose of compilation. But next one is: do you have any opinion related to bcompiler and the alpha tools that we have available on the web?
I'm sorry, say that question again?
Do you have any opinion related to bcompiler in the alpha tools that we have available on the web?
I can't say that I do because I'm not familiar with it.
There we go, easy enough. That is right now the last question I have on the list. If you have a question, this would be the time to do it. Otherwise, we'll let Matthew go. Anybody have any other questions? All right, that's it then. Thank you very much, Matthew. We'll be having the recording of this webinar up on our website the next week or so. So thank you very much for attending, and thank you, Matthew, for giving us this great presentation. Thank you very much.
Thank you for having me.